All right, welcome to the Explainer. Today we're putting on our detective hats because our mission is to decode the hidden secrets of triangles. They really are the fundamental building blocks of geometry, and understanding exactly how they relate to one another is what unlocks the door to solving some of the most complex spatial puzzles out there. So let's build our ultimate deductive toolkit. Here is our roadmap for today. We're going to cover congruence versus similarity, the congruence toolkit, spotting similar triangles, the power of scale, and finally, mastering geometric proofs. Let's get right into it. Starting off with Section 1, Congruence versus Similarity. To really nail down the difference here, think of it like the twins versus siblings analogy. Congruence, those are your identical twins. Same shape, same exact size. If you literally just picked one up and dropped it on top of the other, they'd match perfectly. Every side, every angle, exactly the same, meaning their scale factor is just 1. But then, on the flip side, we have similarity. Similar triangles are more like siblings. You can absolutely tell they're related, they've got the exact same shape and angles, but they can be completely different sizes. One's basically just a zoomed in or zoomed out version of the other, so their sides are proportional, not perfectly equal. Moving right along to Section 2, the congruence toolkits. So if congruent triangles are identical twins, how do we actually prove they're exact copies without, agonizingly measuring every single side and angle with a ruler and a protractor? Look, as a geometric detective, you just don't have time for that. You need shortcuts. Basically, you need cheat codes. And that's exactly what our congruence tests are. They're a set of minimal clues. If you find them, they guarantee the whole triangle is a carbon copy. So let's see what these cheat codes look like. We've got 4 main tests here, and you just need the right combo of clues. First up is SSS, or side, side, side. Prove all 3 corresponding sides are equal, and boom, they're congruent. You don't even have to look at the angles. Next is SAS, side, angle, side. This one needs 2 sides and the included angle, that's the angle sandwiched right there between them, to be equal. Then flip that around, we get ASA, angle, side, angle. 2 angles and the side right between them. And finally, the wild card of the bunch, RHS, right angle, hypotenuse, and 1 corresponding side. Now, huge red flag here. RHS applies exclusively to right-angled triangles. A super common, honestly fatal mistake is trying to use the RHS cheat code on a regular triangle just because you spot a couple of matching sides. Remember, the R literally stands for right angle, and H is for hypotenuse. If you don't have a 90-degree angle staring back at you, RHS is completely off the table, period. All right, part 3, spotting similar triangles. Just like with our identical twins, we have cheat codes for spotting our siblings too. And their names are going to look awfully familiar. We've got AA, which is angle angle. If just 2 corresponding angles match up, the third one obviously has to as well, making the triangle similar. We also have SAS and SSS similarity. But, and this is a massive but, while the letters look the same as the congruence tests, the definitions are totally different. For similarity, SAS and SSS, we are looking for proportional sides, not equal ones. The angles are identical, sure, but the side lengths, they stretch or shrink by the exact same ratio. So here's a rock-solid rule of thumb for you. If you're proving congruence, you're hunting for equal sides. If you're proving similarity, you're hunting for proportional sides. Mixing these 2 up? Yeah, that is hands down the fastest way to derail your whole proof. Which brings us to Section 4, the power of scale. How do we actually measure this stretching and shrinking? We use the scale factor, which is usually just called K. The formula is super straightforward. Scale factor equals the new length divided by the original length. Think about it like this. Let's say your original triangle has a side of 5 centimeters. Now, in a similar larger triangle, that corresponding side has grown to 15 centimeters. Just take the new length, 15, divide it by the original, 5, and there's your scale factor. So our K is 3. This means we've got an enlargement of exactly 3 times. Every single side on that new triangle is going to be precisely 3 times longer than its match on the original. It is a perfectly uniform expansion across the board. But here's where things get really fascinating. We know what happens to the 1D lengths, right? They multiply by 3. But what about 2D space or 3D space? Like, what happens to the area of our triangle or the volume if we were looking at a 3D prism? Does the area just multiply by 3 too? The answer is absolutely not. And this is the dimensional escalation rule. Length and perimeter, they're one-dimensional, so yeah, they just multiply by K. But area is 2-dimensional. It changes by K squared. And volume, being 3D, changes by K cubed. So imagine a scale factor of 4. The length multiplies by 4, sure. But the area, it multiplies by 4 squared, which is 16. And the volume, that multiplies by 4 cubed, ballooning up to 64. Seriously, never ever just multiply the area by the base scale factor. Always square it.
Okay, let's wrap this all together in Section 5, Mastering Geometric Proofs.
To build truly bulletproof argument, you need supporting evidence. You can't just look at a drawing and say, well, it looks identical. You're going to rely heavily on fundamental facts, things like vertically opposite angles being equal, or alternate and corresponding angles on parallel lines. Don't forget that triangle angles always add up to 180 degrees, or that an exterior angle equals the sum of the two opposite interior ones. These facts are literally the tools you use to dig up those missing side lengths or angles, which then trigger your congruence or similarity cheat codes. Let's actually walk through a quick proof. Step 1. Systematically state the facts you've uncovered, like side AB equals side DE, side BC equals side EF, and angle B equals angle E. Step 2. Note what these facts represent from our toolkit. In this case, we've got two sides and the included angle. Step 3, and this is the kicker, state your conclusion with the official rule. You'd write, therefore, triangle ABC is congruent to triangle DEF. Reason, SAS congruence rule. Look, if you don't write down the specific rule you used, you're leaving points on the table. The examiner needs to know exactly which law you applied. We've covered a ton of ground today, so let's distill it down into some real-world survival tips. Whenever you're staring down a geometry problem, your very first move should be asking, am I looking at congruent twins or similar siblings? Figure that out first. Second, when you're dealing with scale, physically write out the length, area, and volume escalation rules on your scratch paper. That way you won't forget to square or cube your K. And third, like we just talked about, always write down your specific rule in those proofs. And just to make sure you're totally dialed in, let's rapid fire some common pitfalls to avoid. First, do not use the RHS test on non-right triangles. I seriously cannot stress that enough. Second, do not forget to square or cube your scale factor for area and volume. And finally, when you're setting up those scale factor fractions, triple check that you are comparing the correct corresponding sides. Please don't divide the hypotenuse of one triangle by the shortest leg of another. Take a breath and match up those parts carefully. Which brings us to our final thought. The actual math here, the algebra, the plugging in numbers and solving for x, that's honestly the easy part. The real mastery happens in that quiet moment of observation before you even write a single number down. So next time you're facing down a messy geometry diagram, I want you to pause, take a step back and ask yourself, before I solve for x, have I checked if I'm dealing with a twin or a sibling? Use your detective skills first, and I promise you the numbers will just effortlessly fall into place. Thanks for joining this explainer, and we'll catch you next time.